Hello everyone, and welcome to the final video in this mini-series where we'll be looking at the future of coal power. So, in the Western world, the plan for coal power is to essentially phase it out with the Paris Agreement that states that the global temperature mustn't rise above 2 degrees Celsius, playing a huge part in this. And one example of this is that the UK has promised to have net zero emissions by 2050, and as a result of this promise, the UK currently only has 2 coal power stations left operating, which are in West Burton and Ratcliffe. So they're being phased out in the Western world. However, in some lesser economically developed countries, such as China, the future for coal is very different. For example, in 2019, half of the global energy that was produced from coal was produced in China, which was over 1 million megawatts. This shows that the energy production from coal in China is nearly doubled within the last 10 years, showing a massive growth in the coal sector. Now, even though the use of coal power is growing dramatically in some countries, it doesn't mean that emissions have to as well, with the development of new carbon capture techniques, such as the Integrated Gasification Combined Cycle, or IGCC. So, during this process, the air is put into an air separation unit, which then splits the oxygen out of the air, and then the fuel, which is in this case coal, is added to a gasifier and gasified into syngas, which is a mixture of hydrogen, carbon dioxide and some carbon monoxide. So this reaction also produces lots of heat, which is used to heat the water into steam to then drive a generator and generate electricity as usual. The hydrogen that's produced is also used as a fuel and can be used in fuel cells to provide energy as well, whereas the carbon dioxide produced that's captured can be stored geologically underground. So once the carbon dioxide has been captured from the power stations, then it is converted into a liquid form and pumped underground for geological storage. So the carbon dioxide is usually sealed in a seal and trap configuration, which is essentially like a dome. So this is the case because the liquid carbon dioxide will float because it is less dense than the water and the reservoir is full of water, and therefore a seal, usually made of mudstone, is required to keep the liquid carbon dioxide underground. A sedimentary rock is usually used as the trap because it's very porous, so the liquid carbon dioxide will be able to permeate the rocks. Saline aquifers are also very useful as geological storage for the carbon dioxide because they are massive empty reservoirs often found next to oil fields, as shown in the image on screen. And this means that large amounts of information about the oil field and saline aquifers are known by oil companies, and therefore less work would have to go in to use these to store the liquid carbon dioxide. So currently, the carbon capture and storage techniques are in a very early phase, such as in 2018, there were only 21 carbon capture storage facilities globally, and 8 of these were in China, with the massive growth of coal in that country. In China, all of the new Coal power plants have some form of carbon capture technology fitted, which is very promising and helps to reduce the emissions. Currently, CCS techniques capture 38 million tonnes of carbon dioxide a year, which is a massive help in reducing global warming. So carbon capture techniques are very, very promising. However, in order to achieve the 2 degrees Celsius global temperature increase limit that was agreed in Paris, it's predicted that CCS techniques need to become 100 times more present by 2040, which is a massive increase and provides a massive task for the world in order to combat global warming. So, thank you very much for watching, and that concludes the final video of this mini-series about coal, where we have looked at how revolutionary coal has been in the past and shown that there may be a future for coal power as well.